Now let's have a look at our vestibulospinal tracts. Tracts being plural, that's because it's made up of both our medial vestibulospinal tract, or VST for short, and our lateral vestibulospinal tract. These are both named after the origin, being in our vestibular nuclei. If we have a look down at our little man, we take a zoom in on our brainstem. We actually have 4 vestibular nuclei, which are located in our caudal pons and rostral medulla, being our superior, our inferior. We also have our medial and our lateral vestibular nuclei. Now, vestibular nuclei are obviously part of our vestibular apparatus, receiving inputs largely related to our sense of balance. If you remember, our vestibular apparatus is part of our semicircular canals in our inner ear for balance sensation. We'll also get some inputs from our cerebellum, which relates to mainly proprioceptive information. So knowing that this is a motor pathway and we've got balance sensation and proprioceptive, we can sort of guess the function. The function being motor control aiming to maintain balance. Now, apart from the medial and lateral VST, starting from different nuclei, they also go to terminate in different areas. Our medial vestibulospinal tract will control mainly the muscles of our head and neck, and our lateral VST will control mainly muscles of our legs, lateral to our legs, both with the goal in maintaining our posture, maintaining our eyes horizontal. So let's have a look at our medial vestibulospinal tract. Obviously, we start in our medial vestibular nuclei. Interesting part of this is that it will project bilaterally, meaning on both sides of the body, down to our upper cervical spine. Once it terminates, it will then synapse onto a lower motor neuron, which will exit via peripheral nerve onto muscles of our head and neck, with the goal of maintaining our head on our shoulders and our eyes horizontal. Every time I think of our medial vestibulospinal tract, I think of this chicken. You can see the chicken's head is maintaining relatively still with their eyes in the same place, regardless of what its body is doing. That is our medial vestibulospinal tract. Next, we can look at our lateral vestibulospinal tract. As I already said before, the L doesn't stand for lateral, it also stands for legs. So we'll start in our lateral vestibular nucleus in our pons. It will then project down ipsilaterally, meaning on the same side, to our lumbospinal cord, where it will then synapse onto a lower motor neuron, exit via peripheral nerve, and innervate mainly the extensor muscles of our legs, again with the end goal of maintaining our balance, so maintaining our erect posture. That is our vestibulospinal tracts.